Good morning. Today's notes, we're going to go over our section 0.3 on exponents and radicals. So you see here some properties of exponents. These are ones that you've used before, but I just want to review them a little bit. The first one is your whole number exponents. So x to some number, remember that just means it's repeated multiplication. So if you see something like x to the it's not working, x to the fourth, then that just means we're taking x times itself 4 times, okay? Zero exponent, anything to the 0 power is going to give you 1 as long as the x does not equal 0. So keep in mind if we have something to the negative power, maybe it's negative 5m and all that's to the 0 power, all of that is going to come out to be 1. Okay, negative exponents, if you have like x to the negative 3rd power, you're going to rewrite that as 1 over x to the 3rd power. So whenever you are moving something with an exponent, if you move it from the denominator to the numerator, or the numerator to the denominator, it's going to change sign. So kind of keep that in mind. If I started with something like this where the exponent was positive and I wanted to move it up to the numerator, then it would be written as x to the negative 3. Okay, your nth root, and the next one, like x to the 1 over n equals n to the square root of x. Kind of keep in mind there something that helps me, especially when you get down into the rational exponents where you have maybe like 2/3 as your fraction. If it is on the root, then it's on the bottom. So if it is the number that's on the root of your square root, so let's say it's something like 5th root of x, then that number, that 5, is going to be on the bottom of your fraction, so like x to the 1/5. Okay. Here we'll do another example. Like I said, if we had x to the 2/3, then we could think of that as 1/3 squared, which then helps you to get your numbers in the right place. So the number that's on the bottom of your fraction is the number that's on your root there. So you would have something like that squared. Okay. And then, of course, we know this, but hopefully you remember, if we just see a square root like that, then we are understanding that there's a 2 on that root. Okay. So operations with exponents, simplify the following expressions and write the operation rule to the right. The first one, we have 3x squared times x to the 4th. So because we have multiplication between here, we're going to use the multiplication rule. Always multiply your numbers first, your coefficients. So here we have 3. This is assumed to be a 1. So 3 times 1 is 3. And x squared and x to the 4th. Since we are multiplying between our bases, that means we are adding the exponents. So this would come out to be 3x to the 6. Okay, so your sorry, I can't write straight like this. So your multiplication rule says if you have x to the n times x to the m, then you will end up adding those exponents together when you multiply. Okay. The next one, we have x cubed over x to the 4th. You really don't need the parentheses there. But here, this is your division rule. If you remember, you end up subtracting. So thinking of it as 3 minus 4. Now this one actually uses a couple of rules here, because 3 minus 4 is going to give you -1. And then we're not going to want to leave our exponents as negatives. So we're going to use the rule from above and rewrite that as 1 over x. Okay, so this is your division rule. And again, that says if we have x to the n over x to the m, we are going to subtract the numerator minus the denominator. Okay. All right, and then the third operation that we have x squared times y, and then everything's in parentheses cubed. So this is what we call our power rule. It should remind you of the distributive property. You have to distribute that power to every base in your sets of parentheses. So if you had a number in front of that x squared, you would have to cube whatever that number was. In this case, when we distribute, we are going to multiply. So 2 times 3 is going to give us x to the 6th, and then y, we have 1 there, so 1 times 3, we're going to have y cubed. Okay, so again, this is your power rule. So if we have x to the n to the m power, we would multiply those exponents. Okay, just some special conventions to remind you of. Make sure that you don't add parentheses if they're not there, or that you don't overlook the parentheses if they are there. So these, in the left-hand column, these are the correct ways to interpret what we see written, and this is incorrect. Okay, if we see something written as negative x to the n power, then that's like us having a negative 1 in front of the parentheses and then x to the n power, okay? We would not include the negative with the variable inside the parentheses, okay? If we have something like negative x to the 5th and we want to evaluate when x equals 2, then we are reading this as 2 to the 5th and then putting the negative out front. So 2 to the 5th is going to be 32. So our answer would be negative 32. Okay. That power is not doing anything with that negative sign. Okay. If we have a coefficient in front, then remember it's just that coefficient times the result of your number to a power. So if we have, for example, 4x cubed, and we say that we want x to be 2. We'll use 2 because that's easy. Then we're thinking of this as 4 times whatever the result of 2 cubed is. So 2 cubed is going to be 8, so 4 times 8 is 32. Okay. And then this one you don't see very often, but just to kind of point it out there, if you have a power to a power, you're doing the power to the power first, and then that new power that you get, you would apply to that power to the x, okay? So, for example, if I had x to the 2 cubed, because apparently I like 2 and 3s right now, we would first do 2 cubed. 2 cubed is going to be 8, so we would write that as x to the 8th, and then if we wanted to substitute 2 in, then we would put, 2 to the 8th power, and we could figure out what that is. Okay? All right. Now, let's go to the back side and look at your radical expressions here. These are expressions. All of them are expressions that we need to simplify by factoring, and they're all involving exponents or powers. So I think one of the most important things that we need to remember, especially when we get to something that looks like number 5, where there's a whole lot of parentheses and everything, your terms, which is what you have to look at when you are trying to simplify. Sorry, that's moving. Terms are going to be separated by your addition and subtraction signs. Term plus minus term. Okay, so you need to look for the addition and the subtraction signs to kind of help you compare what you have and what you might be able to factor out of each term. Okay, so on number 4, you have 4x to the 4th plus x to the 5th. So you need to think about what number you can factor out and then what exponent to a power you can factor out, okay? So if you've got 4 and 1, the biggest number you can factor out of both of those is going to be a 1. If you look at your powers, you can only factor out as much as you have. So x to the 4th is our smallest power. So we could factor out a 1x to the 4th from each one of these terms. Now remember, it's just like you can think about division. If I take 4 and divide by 1, I'm still going to have 4 left. If I take x to the 4th and divide by x to the 4th, we don't have any x's left. 4 plus, and then x to the 5th. If I take away 4, if I think about dividing by x to the 4th, it's going to leave me with just 1x. So this would be our simplified answer. X to the 4th times 4 plus x. Okay. Let's go ahead and do 6. Let's do 6 first. On number 6, you have 2x to the 1/2 plus 4x to the 5/2. Okay. So again, here if you start by thinking about your numbers, you have a 2 and a 4 for your coefficients. The biggest number you can factor out of both of those is going to be the 2. So we know we're going to factor 2 out. Then you have to think about your exponents. So you have x to the 1/2, you have x to the 5/2. 5/2 is going to be the same as 2.5, so 1/2 is your smaller. So 2x to the 1/2 is going to be the biggest number that you can factor out. Okay, so if we have 2x to the 1/2 and we divide it by 2x to the 1/2, that leaves us with 1 plus, okay, now here you probably want to break it down. 4 divided by 2 is going to leave you with 2. X to the 5/2, if you take that and divide by x to the 1/2, kind of think reverse of your operations. If we're dividing, then we're subtracting the exponents. So think about what 5/2 minus 1/2 would be. So 5 minus 1 is 4 over 2, which just simplifies to 2. So this term here needs to be 2x squared. Okay, now again, whenever you're factoring out, remember you can always multiply it back in and distribute and see if you get what you started with. Okay, so 2x to the 1/2 times 1 gives us that. 2x to the 1/2 times 2x squared. 2 times 2 gives us 4. X to the 1/2 times x squared. Here we would end up adding to get 2.5 or 5 over 2. Okay. Now the big one. Number 5 here. This is where you really have to look for your terms, okay? If you look at the numerator by itself, everything's multiplied here. The 3 is multiplied by this set of parentheses, is multiplied by this set of parentheses. So this is one term, okay? Then you have a subtraction sign, and then you have 3 multiplied by another set of parentheses, another set of parentheses. So again, this is one big term, okay? Now we're going to have to do some simplifying in that denominator too. All right, so if we look at the two terms just in the numerator, the first thing you should notice is they both have a 3 in common. So that's something that you're going to be able to factor out, okay? If you look at the x plus 2, they both have at least 2 of those. So I can factor out an x plus 2 squared. And then we should also get an x minus 1 squared out of there. Now I'm going to use a bracket here just because we got all these parentheses out here. I don't want to get confused as to what's been factored out and what's left behind. Okay. If we take this and divide by 3, we're just going to have 1 left. X plus 2 squared, we took all of those out. X minus 1 cubed, I took out 2 of them, so that means I have 1 x minus 1 left in this term. Okay. And then we have our subtraction sign. And then we have to think about what's factored out of here. The only thing we would have left from factoring this out would be an x plus 2. All over. I'm going to go ahead and simplify this. Here we see a power to a power, so we're going to multiply there. And we're going to have x minus 1 to the 6th, again, because we're multiplying. Okay. Now, let's see here. I'm going to leave this the same. And just copy that down. I'm going to worry about simplifying what I have in here. Okay. In here, you need to make sure to distribute that subtraction sign to the x and the positive 2. So we'll have minus x minus 2. And we'll copy all that down. Squared, x minus 1 squared. And then in here, so I'm going to go ahead and change this to parentheses. X minus x, that's going to simplify out. Negative 1 minus 2, that's going to give us negative 3. Okay. Now remember, when you're multiplying, you can multiply in whatever order you want. 1 times 2 times 3 is the same as if you were to do 2 times 1 times 3, okay? So I can simplify this a little bit here. 3 times negative 3 is going to give me a negative 9. And I'm also going to look here. I have an x minus 1 to the 6th power and an x minus 1 squared. So if I go ahead and simplify those terms, I'm going to go ahead and write that x plus 2 squared down, because I can't do anything more with that. Here we can simplify. If I think about subtracting, 2 minus 6 would give me x minus 1 to the negative 4. So I'm going to go ahead and write that in the denominator and have it as x minus 1 to the 4th. Okay. So this would be our simplified answer. Okay. Now we're going to practice with that, but having all of this mess and having to simplify down to this is going to come into play when we get into derivatives. So this is a skill that we need to be comfortable with now, or to work on now, so that when we get to the new idea of derivatives, this is not as scary, hopefully. Okay? Alright, so we're going to stop there and work just on with the exponents and the factoring a little bit, and then as you can see, everyone's favorite domain and range are coming up. Alright? But for right now, we'll stop there.